Okay, this is number 17. Are you ready for calculus? 17a. And what we want to do is we want to find, solve this inequality. So this first one, and with some of these inequalities, graphing techniques are probably a lot easier and straightforward than analytical techniques. So what I did was I just graphed this. I know this is a parabola. I know it's concaved up. It's shaped like a U because this is positive. Okay, and we want to know when that's less than 0. That means when the value of that, the vertical position, is less than 0. So we can factor that and we can find the roots, and the roots are -3 and 1. So if I just graph, I put my roots here at -3 and 1, I know it's concave up, so it's got to look like that. So when is it negative? Less than or equal to 0? Well, that means whenever at -3 it's 0, at 1 it's 0, and in between it's less than 0. So there was your solution. So it's easy to graph that and take a look at that. Okay, letter B, this is another one that's a little tricky because if you just try to solve it analytically, you're liable to miss something. So first of all, we have a rational expression. Now remember, if we're going to graph, if we want to graph this expression here, first of all, and to see when its value is less than 1, that's all I'm going to do. So I'll take a look at this. First of all, I know that I have a vertical asymptote whenever the bottom is 0. So when 3x minus 2 equals 0, all right, that means x would be equal to 2/3. 3 times 2/3 is 2 minus 2 is 0. So I have a vertical asymptote at x equals 2/3. And I graph that over here. You can kind of see it. And then remember, these coefficients, these are both the same power, so I have a horizontal asymptote that's equal to the line y equals, and just the ratio of these two coefficients, 2/3. So that's a horizontal asymptote, so I drew that over here. Kind of see that. So those are your horizontal vertical asymptotes. And then we just tried some test numbers here. And when x is 1, y was 1. So we're over here at 1, 1. And when x is 0, y is 1/2. So this is 1/2. So we get an idea that the sketch looks like this. You could try some more checkpoints, but you could get that feeling. Okay. Now the question was, okay, when is that less than 1? Well, here's the 1 value here. Here is when it's 1, when the y is 1. So it looks like it's less than 1 when x is less than 2/3, because all these points, now here you can see this is the vertical position 1, and all these values are less than 1 here, because this is 1. Now here it's greater than 1 until I get right to 1. Okay. That's equal to 1. That starts to get less than 1 right over here, because and then there's your asymptote of 2/3. So when x is greater than or equal to 1, or when x is less than 2/3. All right. Now you could have solved this if you solve this analytically. All right. You multiply both sides by 3x minus 2. All right. And then subtracted 2x and then added 2, you get 1, and you get x is greater than 1. So you get this by the analytical method, but you would have missed this part. So you have to kind of look at the graph to get this other part. So for x less than 2/3, it's less than 1. And then for x greater than 1, the value is less than 1. Okay, so that's a little tricky. Okay, and then letter C. Again, we wanted to find out when this was going to be greater than or equal to greater than 0, just greater than 0. So this is a quadratic. Again, I wanted to kind of graph it. It's a little bit hard though, because they're going to factor. But I do know it's a parabola and it's shaped like a U. So what I can do is I can find the vertex. Remember the vertex, the x is minus b over 2a, and then we just put that back in the function. B would be 1 and a would be 1, so minus 1 over 2 was the x value of the vertex. When I put this back into this form, I get 3/4. Okay, that would be a -1/2. If I put that in there, I get 1/4. Okay, so I'd get 1 and 1/4 minus 1/2 would be 3/4. So that'd be the vertex. So I kind of graphed it like this, and I could see it goes like this. It's concave up. So I could tell I have no no places where it's going to cross the axis, so it's going to be greater than 0 for all these numbers. Okay, I could also look at the quadratic formula, and I could put these values in the quadratic formula. This is another way to do it. And again, I got an imaginary number. So I had no places where it crossed the axis, so it has no real roots. I know it's concave up. So this is another way to do it. So in both cases, I know that it's always going to look like this. So it's always going to be positive. So when is it positive? For all real numbers. So that was pretty straightforward. That's number 17. So you got a couple ways to do that.